What's up, guys? Mad Chiller here, bringing a quick little overview and build tutorial for the Helio RC Spring Mini 20mm flight controller and the Acon AK32 pin 6S 20mm 4-in-1. The combination opens up a lot of exciting possibilities for lightweight freestyle and racing builds, and I'm really excited to get a couple of these up in the air. So I thought you might want to check out how to wire up your ESC bundle, flash Pegasus, and get it all ready to go. With that, here we go. Okay guys, so here we go. This is your 20mm Helio flight controller. In the package you'll have the FC, you'll have your ESC wiring bundle that goes to the JST on the rear side, and you'll have some shock mount gummies. Now, they crammed a lot onto this flight controller, so it wasn't really possible to get silk screening on all these pads, unfortunately. So you're going to want to get familiar with your wiring diagram. This is your top view wiring diagram. On the top, you got your USB. On your four corners, you're going to have your motor signal pads. In case you want to use arm-mounted single ESCs, you have a motor pad conveniently located on your four corners. This one being motor 1, 2, 3, 4. So if this is your front of your quad, laid out just how you'd like them. Okay. Moving along here, we have a ground. We have camera positive, which is VBAT, and this is a filtered output. So what I would typically do is run my HV VTX's power from these two pads and then power my camera from the HV VTX. This will give you a clean path to ground and a filtered power regulation. This next pad here is your video in from your camera. Then you're going to have camera control, so you can change settings on your camera. Video out to the VTX, a 3.3 for a spectrum receiver, and a ground. Moving along the right side, you're going to have a 5-volt for your RX, FR Sky or Crossfire here. You're going to have S-Bus or RX2. You're going to have S-Port or TX1. And then you're going to have another ground. Along the bottom here, you're going to have a ground, buzzer negative, buzzer positive, another ground, 5-volt for your LEDs, LED control, and another ground. Okay, moving along to the back or rear side. In the four corners, you're going to have RX4. RX4 is for telemetry. So if you're using single-mounted ESCs, you can wire your telemetry wires to these 4 points to get current and telemetry information for your 4 ESCs. Along the top here, we have RX5, TX5, a 5-volt, a ground, a 3-volt, RX2, and TX2. Along the right side of the bottom here, we have our JST for our ESC bundle. Along the bottom, you have TX1, RX1, 5-volt, ground, another 3-volt, RX3, and TX3. Next up, we have the AK32 pin. It's a great looking board, nice thick PCB. LiPo leads are already attached. The motor tabs are clean, they're not pre-tinned. Comes with this Esc wiring harness that I will not use. I'm going to set this aside as I intend to repin the one with the Helio that came with the Helio to match the pin out. Comes with a 330 microfarad cap that I will upgrade to 1,000 as I'm going to run this on 6S. And I recommend you run 1,000 either way. 330 is a little low, in my opinion. And then it also comes with these little spacers that are meant to fit in the top and bottom. There's 8 of them total. They're made out of a hard plastic. I'm not sure if I'm a fan of these yet. I guess I'll see how it actually goes together. If it's easy, cool. We'll see. Comes with a current shunt resistor here. And as I understand it, there are 4 independent current sensors to give you independent current and telemetry information from the 4 ESCs. The last thing that they added that's really awesome is dedicated cap pads here, so you can wire your cap up without having to tag it onto your LiPo wiring. I really like that idea. I really hope other manufacturers do that. I think that's really, really convenient and just so much easier to have dedicated pads for your capacitors. Okay, let's pin it out. All right, so the next thing we want to do is we want to depin this connector here. It fits the Acon, but it doesn't match. If you plug them in as they are, you will blow it up. So I recommend an X-Acto knife, probably the easiest tool for it. You're just going to want to very gently pry up on each tab on the JST here and pull all the wires out. And then I've made a diagram to put them where they need to go. And I recommend you do this. It will make your life so much easier, or you can watch this video and pause it or whatever you need to do. But definitely make a diagram, make sure, and then check it 3 times before you actually plug it in. Okay, so here we go. These wires are actually a little slippery. And you're just very gently prying up, get the wires out. It's also important to realize which way is up. These pins only go one way correctly, and you will want to make sure that you put them in. So as I'm pulling these out, the little tabs are facing me. All right, so let's bring up the diagram here. Okay, as you see, I've taken the 2 diagrams and I've set them side by side as we have the actual boards in reality. Okay, so as we go here, we're going to want to make sure that we lay these boards as you have your diagram. Triple confirm you have everything laid out properly. Otherwise, it will be bad. Now, some people like to just snip these and resolder them, which is totally fine to do as well. I do not like to do that. I find all the extra shrink wrap and stuff, it not only does it look bad, but it's harder to deal with your wiring afterwards. So I prefer to do this method and actually very gently repin the whole setup. And then that way, I don't have any of that mess. Also, I like to tie my cables into a little overhand knot just to shorten it all up and clean things up when I'm done. So having all that definitely makes that harder to do. Okay, so we have the JST separated now. Now it's very important that you line up the JST properly so you know which way it goes. And what we're going to do is we're going to start with the power first, just so we get those 2 right. That's the most important thing. So if you don't have power quite right, you will, yeah, you'll have problems. So here we go. So there's the power on my diagram. I'm going to take VBAT into BAT positive and ground to ground. Now remember, those little tabs need to go towards the tabs on the JST, which I had to flip over. So you have to be mindful of this as you put them back together, otherwise they'll just fall out. So the battery connector is the second pin in, and I'm just going to very gently push that in. Next up is going to be my ground wire. Again, you want to make sure their pins are going in the right direction. That's actually the first one here. But once you get them started, I just kind of wiggle them. It's really nice to have a set of tweezers to help with this little organization. And then once you have them in the right location, you want to just push them in and then push back down on the little tabs that you pried up. And I highly recommend that once you get them in, you just gently tug on them. Just make sure they're not going to come back out. Wiggle them a little bit. And once those are good, that's your ground and power. Again, you're going to verify this by plugging it in, making sure that it matches your diagram. On the Acon, there is some silk screening on each side of the connector that will help you in this process. So, one other thing that you'll notice is that there's one pad or one connector, one pin on the Helios labeled not connected. So I normally just do away with that wire altogether. It's not connected, so you don't need the wire. And that wire in this bundle is this, on my bundle, it's white. It's the fourth one away from power. So it's this white wire right here. I'm going to go ahead and get rid of that now. Okay, that's gone. Kind of bend that one back down. Okay, so those are good to go. The next one in from power is this blue wire here, bluish green, sorry. It's kind of a turquoise. That is going to be your telemetry cable. So we're going to move to that part of the diagram. I left these separated so they're a little easier to read. Telemetry is the first pin here on the Acon. And again, oh, see, it came back out. So once you get them in, pull your JST back off. Use some tweezers, something just give a little push in, and then push down on the tab to help lock it in there. And usually, oh, I didn't quite make it. Once you get it in and you push down on the tabs, it's going to lock. And again, you just want to wiggle it back and forth very gently to make sure that it's not going to come back out. So I have left here my 4 motor wires. Now, with the Acon, this is the back of my quad, and I have my leads going back. Acon has done silkscreen. Motor 1 is here, as it should be. Motor 2 is there. Motor 3 is here. And motor 4 is there. So that means that in theory, as long as you're not doing anything weird, if you're keeping everything orientated naturally, shall we call it, say. Um, if this is the way you put in your Acon, you're not flipping it upside down, which I actually like to do in many cases, but if you're just doing the standard tabs up, easy peasy, then you don't need to remap any of this. This is going to lay out exactly the way you want it. So, having said that, I'm going to plug this back in really quick. Just make sure everything's lining up. And this yellow wire here, which I marked in yellow on my drawing, should be motor 1. Motor 1 is the first one past VBAT. So this is pretty simple. We're going to go motor 1, boom. And then the next wire, your blue wire, is motor 2. And same thing. Just gently get it in the hole. Give it a little push. Don't worry about getting it totally right yet. You just want to get them in the right spot. And then motor 3 should be in. And finally, motor 4. Once you have them in the right spot, flip it back over, grab your tweezers, and just give them a gentle little push in, gentle little push in, gentle little push in, gentle little push in here. Once they're all in, just push down on those tabs. These are the ones that are notorious. Like, you really want to make sure you get these right. You don't want to have a motor not, or an ESC not arming for whatever reason. You want to make sure these are all in correctly and that they're not going to push back out when you actually plug this in. So just give them a little back and forth wiggle. Oh, see, there's one. Motor 1 almost came undone. So you just want to get it in there nice and tight. Make sure you push down on the tab. Get it locked in. Give it a wiggle. Now, last but not least, we are missing current. So on the Helio, current is this little circular pad right here. Now, as I understand it, the latest version of BL Heli has added current information into telemetry, even when you're using multi-shot. So it may not be necessary to use it anymore because it is technically already going to be part of telemetry. But if you want to be sure, and you definitely, if you're a current guy, you want to make sure you have your current readings, then you can go ahead and wire that up to that little round pad there. I'll just go ahead and do that. I'm just going to steal a wire off of my ESC bundling here, just so I have it, and won't bore you with me soldering it on there. I'm just going to do it and come back to that. Oops. And this one's being a pain. Come on. There it goes. Okay, so I've got this blue wire here, and I'm going to just, again, you just want to make sure you put it in the right way. The little, you won't be able to see it probably from my camera, but there's a little tiny tab on the back side, I call it, of these pins, and you want to make sure that's going towards the plastic tabs on the other side. Once you get it in there, same thing, just push down on the plastic of the JST and push it in, and then usually I just pull it back and give it a little wiggle. Make sure you're good. And that's it. So, can't stress this enough. Before you plug it in, anything of that nature, triple check it against your diagram. So going back, once I plug this in, and the silk screening. It's very important. Silk screening diagrams aren't always correct in these things, so you really want to make sure that you check it. So having said that, we'll go back to our power diagram because that's the most important. And I've got red up here coming down to the red over here as on my diagram, and also it matches the positive mark on the silk screen here. Helio positive, Acon positive. Then the negative black wire, which is the third one down on my diagram, coming into the first pin here on the Acon side. Those are the two most important ones. And then moving back to all the other goodies, you got your green telemetry wire coming over here to the top of the connector as it should be. And then your motors, yellow being motor 1, going over to ESC1, which is just the first one past positive. Bluish turquoise motor 2 is in line. Green motor 3 is next in line. And the white motor 4 is last, with this wire actually that I added for current that I will solder onto the pad later on. Okay, that should be your pin out. Now, one thing I recommend before you do anything is get a meter. A lot of people use a pop stopper, but if you just put a meter on your LiPo wires and check for continuity, you should not have constant continuity. It might give you a tone for a split second, but it will stop, and that means that you do not have a short. So I always recommend before you do anything further, just check that, and you should be good to go. Okay, guys, so we're in a good place now. We've got the pin out done. That's really the hard part. This will make it cleaner. Like I said, I normally actually tie a really loose overhand knot in my ESC bundles when I'm putting these together to help just kind of take up the slack. Couple things. When you're going to flash, and as you you're building your rig, these boards can run several different types of firmware. So you want to be aware that sometimes certain firmwares may or may not require that you have something plugged in on a certain UART. So one thing to note is that the current race flight builds are, I believe, are still looking for your transmitter to be on UART2. So if you're using FR Sky, that's pretty easy. But if you're doing Crossfire, you should tag that onto UART2. Just that way you can go between Butterflight or Raceflight or Betaflight. It will always be on UART2. And as Raceflight uses DMA for the RX, it's not currently an option, but it is being developed to be able to change the UART. So for now, if you want to use Raceflight, UART2 for your RX. That's important. Okay, so let's go ahead and plug her in to Pegasus. Okay, so the board is ready to be flashed. Spring Mini came with Butterflight 361 on it. So we're going to want to go ahead and just update it. And to do that, we are going to want to come over to this little keyboard here and open up CLI. And we are going to want to type BL for bootloader. The spring will reboot, and then we will pick our firmware. If we wanted to flash Raceflight, there's Raceflight. We can pick the latest version and put that in. But I'm going to start with Butterflight for now. This is a cinema build. I'm putting a few unique things on here, so I want to actually run Butterflight on this. And I'm going to go ahead and select Helio Spring, and I'm going to select 362, and then I will type flash. You get the little dancing banana here, and it takes a couple moments. And it's important to note while it's doing its thing, do not unplug it If you made a mistake or anything, just let it do its thing. Don't ever unplug it when you're flashing firmware. You could have a bad time. Okay, so once it's flashed, it's going to do its little reboot thing here. And once that's done, the next thing you are going to want to do is update your imuf. So you're going to come over to version info. And you are going to be able to see here, you'll see butterfly. The target is Helio Spring. You're going to see your version number, and you're going to see your imuf version. Helio is constantly updating and changing and trying new things, so you'll see some experimental builds here. But the current release version is 1.10 Starbuck Fully Unleashed. I'm a tester and pilot, so I'm going to go ahead and I'm going to try experimental only 8. We've been having really good success with 8, 7 as well. But these are test versions for us to check out. So we're going to go ahead and put 8 on here, and when you select it, you're going to hit flash. And again, it's going to do its thing. It's going to talk to the imuf, download the latest build, and go ahead and put it on the in the imuf chip. Same thing here. Just let it do its thing. Whatever you do, don't unplug it. Just takes a few moments, and when it's done, it's going to go ahead and do its reboot again. And it will reboot. So the first thing I usually do is just go ahead and calibrate the accelerometer. Just have that ready. And then from there, the next thing you're going to want to do is go back over to CLI, come in here and set CPU overclock equals 216 megahertz. Oops, megahertz. You're gonna hit enter, and it will confirm that it is set correctly. Check that, and when it's good, you know you're good. Go ahead and hit save and enter. It's going to reboot again. And come back up. The reason for this is I'm going to run 3232 multi-shot, and it keeps my CPU in the mid 30s. If you want to reduce CPU load further, you can disable your accelerometer. Just selecting 32K. And each time on each page, as you make a change, you make your changes, just make sure you hit save in the top right corner. That way you don't lose any of your settings as you go. And if you want to, you could disable your accelerometer right here. Okay, so that's good. And as you can see, currently I'm running about 37%. Now, if I turn off my accelerometer, it drops it down to 29%. So that's an option if you're concerned about high CPU. I've never had an issue in the high or the upper 30s. So I'm gonna go ahead and turn my accelerometer back on. As I said, this is gonna be a little cinema rig that I'm building, so gonna need that leveling. So once that's done, one other important thing that I'll mention is that under advanced, there's a lot of settings here, but one thing that I always set on every single quad is small angle. So I'm going to go ahead and just type small, and that brings up max arm angle. So I'm going to set this to 180 and click off and click save. So this means if I get stuck in a tree or I hit a gate and I'm hung up and I'm kind of upside down or at a weird angle, it will go ahead and arm anyway. All right, so pre-flight check. Right now I have no RX. Well, I haven't connected one yet, which I'll be doing in the next video as I build the quad. I do like to kind of just set up some basics as I know what I'm planning to do. So I'm going to go ahead and just go to ports, make sure that my receiver is on UART2. It's currently set to S-Bus. I'm going to go ahead and set my smart audio up on UART5. Go ahead and hit save there. Okay, so if you haven't used Pegasus, it's set up very similar to most other configurators. A couple things are slightly different, but you got your PIDs tab. You can show your TPA curve if you need some TPA in mid throttle or low throttle. You can always come in here and tweak your curves, tweak your PIDs, set your auxes for arming, buzzer, all of that stuff here. You'll do your motor layout. You have your orientation and motor assistant here as well. Air mode switch is on. And lots of additional settings here for mid throttle and whatnot. Rates, voltage and current settings, your receiver tab, which this brings me to a good point. One thing that I always do, I run TAER, not AETR. So to change that, you want to actually come in here and you're going to type that in manually. This actually allows you to type in, you can have any combination of controller mapping you want, but standard is TAER. And go ahead, set that and hit save. And then once you get your receiver set up, you can run your receiver assistant. Go ahead and help set that up. And then come over, set up your OSD. If you're using GPS, you can use that there, do that there. You can even preset your favorite channel for your smart audio, and your power band. So I always set up mine on race channel 8, 200 milliwatt. Go ahead and save. So when I hook up my Unify, I'll have that will automatically come up set on the right channel for me. And that's pretty much it, guys. That's the gist of Pegasus. I will touch on this further in the next video. One last thing I will show you is the filters tab. This is where you can set imuf Q settings and low passes for your axis, and you can adjust your sampling window. Sampling window is how it's looking at the noise, and for a larger quad, you will want to raise this number. 5-inch quad, a good place to start is 32. If you're running a smaller racing quad, you would drop it down to 16. On a 6-inch, you would go up to 64, possibly 128. 7-inch, you would be at 128 up, and so on and so forth, all the way up to 300 or more, depending on what size craft you're running. So this is an important one to know. Sampling window. But for 5-inch quad, start at 32 and then take it from there. All right, guys. Well, that's it for me. I hope this helps you get up and running with the Helio Spring Mini 20mm and the AK32 pin. And if you have any questions, leave them in the comments. And if you enjoyed the video and you find it helpful, please smash the subscribe button. And thank you, and send it.